Students, today I will discuss these particular points at their intermolecular forces of attraction. We should know that the attractive force that exists between the adjacent molecules of matter are called intermolecular forces of attraction. So, if it is matter, then the constituent particles are molecules. Okay, so what is the intermolecular forces of attraction? Suppose this is molecule A and this is molecule B. So the attraction between them, there is some forces of attraction between them. This is known as intermolecular forces of attraction. Okay, so intermolecular forces of attraction. Okay, clear? So adjacent molecules, that means the atom next to it, okay, there may be intermolecular forces of attraction. I think it is clear to you. There are two types of intermolecular forces of attraction. First one is cohesive forces of attraction, when the forces of attraction occur between the molecules of same substances. That is, suppose it is A, it is also A, both are the molecules of same substances, then this type of force is known as cohesive force. But when the forces of attraction occur between the molecules of different substances, that is, it is suppose it is molecule A or it is molecule B. So the forces of attraction between them is known as adhesive forces of attraction. Hydrogen, and this is also hydrogen. The forces of attraction between them is known as cohesive forces of attraction. When water molecules attracts the glass rod, it is also glass rod molecules. This is known as adhesive forces of attraction. I think this is clear. Now I am going to discuss about the comparative study of three states of matter. So three states of matter are solid, liquid and gaseous. This is clear to you. So first point is packing of molecules. As you know that solid substances are very closely packed. Clear? In case of liquid, they are loosely packed. In the previous classes, I have already discussed. And in case of gases, the molecules are far apart from each other, so they are very loosely packed. This is clear, I think. So first point is complete. Okay. Next is what intermolecular forces of attraction. Okay. What are the intermolecular forces of attraction between solid particles? So we already know that it is maximum because they are very close from each other. So the intermolecular forces of attraction is maximum in case of solid. And in case of liquid, it is slightly lesser than solid, but greater than gases. Okay, and it is negligible. The forces of attraction is negligible because the molecules remain far apart from each other. So in case of gases, the intermolecular forces of attraction is almost negligible. Okay. Next point is intermolecular spaces. We already know that there is particularly no gap in case of solid, okay, in between their molecules. So it is very less. Okay. In case of liquid, it is the intermolecular space is greater than solid, but less than gas. Clear? And it is highest. That means maximum. Intermolecular space is maximum in case of gases because they are far apart from each other. And number 4 is types of movement of molecules. The types of movement of molecule in case of solid particles, that they vibrate at a fixed position. That means they are at fixed position, cannot move. Okay, but in case of liquid, they vibrate to and fro and around their axis and move from one place to another. Clear? But in case of liquid, they are always more gas. They also vibrate to and fro, rotate around their axis and move more randomly okay. That is, it is vigorous in case of gases. So I think this is clear to you. Okay, the comparative study of physical properties of matter. Okay, so physical properties are basically mass, volume, shape, density, rigidity, compressibility, and so on. So we can discuss it one by one. So as we already know that matter must have some volume, or they must occupy some space. So they have definite mass. Okay, each one have definite mass. Okay, liquid also have definite mass. Clear? And gases also have definite mass. Okay, next point is volume. Solid have definite volume. Okay, liquid, suppose in case of brick, they must occupy some volume. Okay, in case of liquid, suppose this is the water, and they must have definite volume. Okay, but gases does not have any definite volume. They can be anywhere. Okay, so these are the 2 points. Third one is solid have definite shape. Okay, liquid does not have any, definite shape. They occupy the shape of the container. That means they take the shape of the container. They take the shape of the container. Okay, and gases does not have any definite shape. Clear? Okay, if we consider the rigidity, they are very rigid. That means they cannot flow. But in case of fluid, they can flow. Okay, and it is also, gases also can flow. Okay, so they are not too much rigid. Next point is thermal expansion. It is very low in case of solid, but in case of liquid, it is slightly greater than solid. That means if we give thermal energy to liquid, it can be expand, okay, to some extent. But in case of gases, it is maximum. Okay. Okay, that means by giving thermal energy, that means by giving heat, gases can expand at maximum. Okay, gases can expand maximum. Diffusion, Solid, in case of solid, is very low because these molecules are very rigid, but liquid can diffuse to some extent. Okay, so it is slightly greater than solid, and gases can diffuse very randomly. Okay, can diffuse randomly from one place to another. So these are the physical properties of matter. Okay,